In the last section, we looked at balanced equations and talked about how you can convert the coefficients from representing like one molecule of N2 and 3 molecules of water to forming 2 molecules of NH3. It can be read as 1 mole of N2 reacts with 3 moles of H2 to form 2 moles of NH3. We also discussed that this ratio of 1 to 3 to 2 holds true, and you can multiply the entire equation by the same multiplier and the ratio will still hold true. So in this case, 3 moles of N2 produces 9 moles of H2. Reacts with 9 moles of H2 to produce 6 moles of NH3. But when you're in the chemistry lab, often you will have an unusual number of moles, and so you don't, and then an excess of another of the reactants, and you need to figure out how much of the product you're going to produce. So in this case, I have 4.5 moles of N2 and an excess of hydrogen, and I'm wondering how much NH3 I can produce. In this case, and in all the problems today, and really you'll use this action throughout the rest of this chapter, you look at the original ratio in your balanced equation. So in this problem, we're concerned with N2 and NH3. We look at the balanced equation and we see that for every one N2, we needed 2 NH3s. So that ratio holds true, and so in my new situation, I have 4.5 of N2, and I'm wondering how much of NH3 that I can form. And you can set up these comparable ratios, cross-multiply, and you get that with 4.5 N2, you can form 9 moles of NH3. And those of you that are really paying attention to this realize that you need to also state you have an excess of H2, but that will show up in all your problems. This is one way that you might be comfortable solving this type of problem, but we've also talked about this way, which is dimensional analysis, that you set it up so that you take what you're given, 4.5 moles of N2, and you multiply it. That's what these two hatched marks next to each other represent. You're multiplying it by the ratio that will give you the value that you're looking for. So 4.5 N2 multiplied by the ratio of 2 NH3 per 1 N2, which I got from the balanced equation. My N2s cancel out, and I end up with the same thing I did up here, 9 moles of NH3. So for this lecture, I'm just going to give you several more examples of what we call mole-mole conversions to get you ready for more complicated conversions in the next couple of lectures. If I read 45C, I see how many moles of carbon monoxide form at the same time that 0.246 moles of CS2 forms. In the problem, you're given your balanced equation of 5 carbons reacts with 2 sulfur dioxides to form carbon sulfide plus carbon monoxide. And they are wondering how much carbon monoxide you can form with 0.246 moles of carbon disulfide, or carbon sulfide rather. So we can do it. With my experience, a lot of kids feel comfortable with this way that I showed you on the other slide, where you compare the ratios XCO to 0.246 CS2, and then I go to my balanced equation and I see that ratio is 4 to 1. It's important when you set these up that your ratios are the same. So here I have CO on the top, CO on the top, CS2 on the bottom, CS2 on the bottom. That's a common mistake. Then you cross multiply and you end up with 0.984 moles of CO. I would really impress upon you to try to do dimensional analysis, and with that you put what's given, 0.246 CS2, and you multiply it by what is referred to in your book the mole ratio that gets you the value you want. And from your balanced equation, you know for every 4 CO you get 1 CS2. When you multiply these out, the units of CS2 divided by CS2 converts to 1, and you end up with 0.984 moles of CO, the same as we did using the other method of comparing ratios. For your homework, I would like to for you to complete this worksheet. I have started it for you just to give you a feel for how to solve these problems. If you have any questions, feel free to talk to each other or email me with any questions that you have. This worksheet is posted on campus. Please download it into Notability, complete it, and upload it at the time designated with the on-campus instructions. Thank you. Oh, by the way, those of you that were paying attention on screen 2, I should have consistently called CS2 by its correct name, which was carbon disulfide. Bravo for you that picked that up.